Welcome back to this session of oxidizing code. And what we're trying to do is to understand borrow checker one little piece at a time. So on the last video, we arrived at this step over here. So we have two structures, one that represents a particle and one that represents a velocity. And what we're going to do is in the last video, we're just updating this particle 10 times inside a for loop. Now that we understand the for loop, for sake of simplicity, we just leave aside the for loop. But what is going to happen is very simple. So we replicate a for loop, copy and paste twice, and we can see in this code that we take as an input one particle and velocity, and we return both of them, particle and velocity. This lets the code compile, and actually that's what we want. However, it's clearly is not practical, so let's make sure that everything runs good. Particle 77, which is just 2 times 2, 4 plus 37, 3 times 2, 6 plus 1, 7, 7, 7, good. So clearly it's not practical to just return both arguments. And the important point to understand is that in Rust, when you pass something as a value, like in an update state, you pass the particle p and the velocity v. In the line after, p is not defined anymore. So, for example, let's suppose we want to print p with 0 is here. This will not work, which is complex stuff. But I move it here. This is what we're trying to understand what's happening. So, in this case, we say that the function takes ownership of p and does not return it yet. So clearly this is impractical for pretty much all purposes. So we end up using a reference. So reference are pointers. You can consider them like pointers in C. They are a little smarter than pointers, but the theory is similar. Oh, this one. Good. So let's go to this other snippet here, which is very similar. But the main difference is that now update state takes a reference to velocity. So reference is a pointer in C, like superior, similar to pointers in C. And what are just the address, so they contains a number, which is the address in memory of this case velocity of the object. So okay, the difference of this code and this other one is very simple. Is that this code takes a reference on the velocity and returns only the particles. So this is a particle as a value, a reference to velocity, and returns a new particle. How do we use it? Very simply, we just call update state of p and the reference or our velocity. And then again, update state passing p01, this one, and then the reference of our velocity. So it's important to believe that this code works. Good. It's doing exactly the same thing as before, but this time we don't need to return the velocity to the callee. Yeah, we don't return the velocity. Why? Because the reference let us pick in the values without actually owning it. Hopefully this is clear. I'm not sure it's clear, but if it's not, just let me know. Now, one thing to understand is that I cannot do something like this. So this will not work because p after line 44, after here, does not exist, is not usable anymore. It was just already swallowed by the state. So it's not anymore something that you can use. Let's see. Exactly, line 44, value over here, value move used after move here in foo. See that this value you cannot use it anymore because it was swallowed, was taken by the first update state. And what we're doing here is create a new variable, p1, and passing this new variable. So let's make sure it will work. Oh, good. Let's go a little forward. We understand what is a reference, which is an address to an object. And we see that if I take the address to the reference, the object is not swallowed anymore. It's not taken anymore by the function. It's borrowed to the function. So after the function finish, the object is still there. So like in this case, after that update state finish, the velocity, this one, that we take as a reference, is still usable by the function. Let's go a step forward, a small step forward, and see what's happening if you define another struct that our universe. Our universe contains one particle and one velocity. We take the particles as value and velocity as a reference. So very similar to what we're doing here. Like we take the particles as value and the velocity as a reference. And you will see that here we have the same error. Oh, sorry. Whoop. Ah. So again, what is happening? The universe is taking ownership, it's called in Rust, of the value p. And then here in 966, 966, volume over here, 68, okay. And then we try another function, update states, try to read p, but p is not there anymore because it belongs now to universe. And immediately, line 17, this one, here, this is update state, value is here after move. So first, we take this value p, we create it, okay, and we let universe take it as value for us. From line 68 onward, p is not accessible anymore. So now on line 17, then we try to use p, we get this error. Okay. I hope it's clear. If it's not, just let me know in a comment below and we do it again. So what is the solution to this problem? The solution to this problem, I will say, okay, why we don't take the update states and then we need, do not take the particle itself, but a reference to the particle. And this code is load. Let's see what's happening here. Same problem. Even the reference is not there anymore. The value p does not exist. Here, after line 65, even if now I try to take a reference, in line 64, here the universe swallow it, take it from us. We cannot use it. One possible solution in this case would be to have the universe taking itself a reference. Now, see what's happening now. So the universe Now have a reference to P and a reference to V. And then here we require a reference to P, okay? And here we require another reference, no, we require a reference to P1. So this should be okay. Actually, let me show it's actually okay. Good. But let's be careful what's happening. So these two updates, now we're going to PO2, which is this one, updated twice, 77, the same value as before. The universe, P1, is still referencing to the original one, to this one, 3 and 1 here. So it's important to understand that this original P did not change. So good. Next step is to say, okay, but what if I want to change, I want to create a function that acts on the universe, like our function here, update universe. So our function update universe take a reference to the universe and modify it. But let's remember that for modifying something, we need something to be mutable. So we take a mutable reference. Okay. So what's happening here? We went back to the universe that swallow the particle, that takes completely ownership of the particles, and we just update the universe twice, and then we print it. This does return start code, new code. We see the function update state. This one is never used, okay, but this does return the same result, because the universe, all the particles, we update it and then update it twice, and we get the same result. It's fine. Let's go one last step forward. Comment out this one. Yeah, now we want to do something even more fancy. We want to have the possibility to do both. To update the state both by to update universe that act on the reference of the universe, but also to use the update states. So if we think about it, it's very dangerous, because we are taking a value and our reference to that value. The value is pushed, is swallowed by the universe, so the particle is swallowed by the universe. But we still have the reference somewhere, and we're going to mutate. We are trying to mutate that value by reference from some other part, but the particle belongs to the universe. So let's try. Well, our struct contains a particle as valued, so it's not a reference. And the velocity, okay. And we have the update universe that takes a reference to the universe, update based on the velocity, and that's pretty much it. So we do it twice, and then again we print. And just verify yes. And this works fine. But now let's try to call update the old update state. So we really understand that this should not work. Let's make sure. Same error as before. The universe swallow refers this ownership of P. And now this function update state tries to use P, but it cannot. P is not there anymore to use. What we can try to do Well, maybe what if update state is a reference to the particle? What's happening in this case? Let's see. Oh, oh, let's go back to the suspense. Pop, pop. Here, same problem. Our universe in line 154 here takes ownership of P. So it does not exist anymore. Even taking a reference just makes no sense because P is not there anymore. There is nothing you can take a reference of. One alternative would be to move upward. So let's see what's happening in this case. Same result. Why? Because we take a reference, we do not touch it, we don't modify it, and we create another values. After this line, P is still valid because we took a reference. So we borrow P, we didn't touch it, and then this function update states, function over here, finishes, the borrow is over, and then somebody else can take P, in this case universe, that does all its job of mutating stuff. So this is work. Now let's try to be a little more nasty. Let's try the update states over here. Let's try to modify the variable underneath. So the first thing to do would be to particle 0 plus equal velocity 0, and then particle.1 plus equal velocity.1. Good. So let's see what's happening in this case. So, want us to return something, we just do not want to return anything because update states actually update should update the particle, okay? File. Oh, oh. Let's go back, let's try again. We don't care about this one, but this reference, so that cannot be written. Help. Considering change this to be a mutable reference. So we need to tell Rust, look, inside this function, I'm going to change my particles. So P1, we don't care about P1. Oh, and when we use it, we want to ensure to pass it as mutable reference. Okay, this particle must be declared as mutable also. It's working fine. Because what is happening? Update state will mutate P, and the universe will take the new P mutated. So the result is different. It was 7, 7, and now we add 2 to 9 and 3 to 10. Okay, this is roughly the result we want. And we update the universe twice. Let's see what's happened if we move this one over here below. So first we create the universe, and then underneath we try to change the variable that computes the universe. Done. Same problem as before. P is valued, is take ownership of P after line 1.5 here after this line does not belong anymore to does belong to universe. So update states cannot use it anymore. Same issues of before. So now you can say let's try to take the ownership, the reference in the particle. So something to do like this. And here send the universe itself with the P, and this will raise an error. Simple one. So like this one. Here in update universe, we are trying to change the P1, but we cannot because it's a reference which is not mutable. Here Rust suggests us to consideration it is to be mutable. Good. Then there is another error that we'll understand now. Around, then again, when we pass the reference, we want to pass it as a mutable reference. So we say, yeah, this is mutable. Okay. And this is the other point. You cannot have two mutable references at the same time. So the first mutable reference is clear, it's one. It's this one. The one mutable P, this reference here, and it's one. It will be fine. But then there's another one. This update state here. Now be careful, is the fact that this is here does not change anything. And if I put here, it will be exactly the same problem. Okay. So the point is that Rust does not allow us to have twice the possibility to mutate the same variable. So the first time will be here, so universe, as a particle still exists, you can access it, but not as long as universe is living, because universe has a mutable reference to the particle. If you try to access it, like we do here, with a mutable, even with a mutable in particular, we will see that the borrow checker will not allow us to do it. So we remove this one. See what's happening now. Good. Okay, so I hope this short, it's not so short, this video was useful. And if you have questions, let me know. I will answer. Let me know by whatever on GitHub issues or on here on YouTube. I will try to answer. Thank you.